Welcome to Constant Variables, a podcast where we take a non-technical look at building and growing digital products. I'm Tim Bornholdt. Let's get nerdy.
Welcome to another episode in our Oofda series, sponsored by the Jed Mahonis Group. In this series, we bring on a guest who's a subject matter expert, give you a bite of what you need to know about said subject, and share resources where you can learn more. While you're listening to Tim's conversation with Jason Walker, please take a second to rate and review the show on Apple Podcasts. If you help us out with a rating and review, we'll thank you with a shout out on the show. Visit constantvariables.co/review and we'll take you right there.
Hey, Jason, welcome to the show.
Hey, thank you very much. Great to be here.
I am very excited to have you here today. I'd love for you to tell our audience a little bit about yourself and how you got into this crazy world of tech that we play in.
Yeah. Jason Walker. I've been getting paid professionally for IT work. It's in the unit of measure of decades. Started early as my grandmother, my mom, was a big supporter of my interest in tinkering. And way back when I was a kid, she bought me an IBM ATXT dual 5 1/4. It actually had 16 color screen. It was like top notch. Yeah.
Smoking.
Yeah. And I remember, and at the same time, it was like, I was also a big fan of like Mad Magazine. And there was an Alfred E. Simon, what me worry program you could type into BASIC. And so I remember sitting there typing that out an entire weekend and expecting this magical thing. And it was just like this silly little image. And at the same time, I was like, I can make this program do more. And I think that I've always had just that inkling for on the technology side and just like messing with things, wanting to be a builder and a breaker of things. And that just moved into a clear line of sight when I hit, I don't know, right around 20, and an opportunity at a company opened up, and I was able to show some aptitude and acumen, and given a great opportunity with Chase Bank. They put me in as a desktop analyst to start working on some computer programs and different things in the call center. And from there, it just took off. I currently am a director and an architect at American Airlines. Been there for coming up on almost 2 years. My journeys have taken me everywhere from, around the world doing different things with different people, whether it's like hands-on coaching, if it's deep into programming. There were a couple of times where I've had to pull T1 lines for telephone lines, like through a sewer. So it's been like all the way through all the different things that you potentially have to do in the IT world. I've had at least an opportunity to get my hands experientially dirty through the journey, and it's been great.
There's not very many times that I wish our podcast had video, but I wish you could see the smile I've had on my face, like the whole time you were telling that story about like typing the program in from Mad Magazine, because that's just, it's so awesome that people, I just love when I meet other fellow tinkerers, really, is what it comes down to, because I feel like that's two peas in a pod where you're like, you get the thing done and you get it built, and it's like, all right, well, that happened, now what can I do? And you just keep playing with it and keep messing with it. And I wish like more people had that same desire to keep tinkering and exploring and expanding. And that's kind of the energy I like to try to put out there, of especially with this podcast.
Yeah. And I think with the topic that we have today, I think one of the pieces that comes into play is around that tinkering is that I feel like it taps into not only like the creative side, but one of the, like, I want to say like the danger side is, and this is part where like I have to make sure I keep it in check. I have to scope it correctly. Like it's very scientific method, right? Like it's almost, and maybe if you don't like it almost like you have to kind of train yourself a little bit to go, I'm going to try this one thing. I'm not going to try these 20 things because I want to know if this thing works.
Right.
And then like, oh, that worked. Okay, cool. Now let me add another thing, but don't break the first thing. Did that work? And if I break the first thing, it's like, okay, no. Let me reset. Let me figure out my new variables. Let me figure out my new dependencies and then move that thing forward. And that is just like, you have to practice that. That's part of that 10,000 hours of mastery. And that's I think is a big thing that, again, going back to my mom and her just like, hey, try this thing out. And I had like that one chance, and I think it was like, it was like $4,000. She had to, she dipped into savings and was like, this is the future. You need to figure this out. And I was like, oh, this is awesome.
Yeah. I think, that I'm thinking about how I need to go up and fix my dishwasher that's been broken for like a month and a half. And I've already gone through and tried to debug it in the same way where I'm like, okay, so the problem is water isn't getting into the dishwasher. So which of these components can I just buy a new one of and rip out and put a new one in? And I've been like on backlog with parts and now they're sitting up there and I'm like, okay, that just got me excited to go and fix that this weekend. So thank you for that. But, like you said, we're here today to talk about software dependencies, which it's a pretty broad engineering term, and we're only going to really scratch the surface here. But I'd love if you could maybe start us off by defining what a software dependency is, and maybe give some examples of how much we all rely on third-party libraries in order to get our jobs done.
One thing in thinking about this topic, the software dependencies, and we'll definitely get into that. I think there's other dependencies that people like, and we don't necessarily need to get into the weeds on all the different aspects. I think there's other things that people could probably take away from this and go, yeah, let's also think about these other aspects of dependencies, but specifically to, that third party software library, software supply chain. That's I think when you hear about all the ransomware topics or stories that are out there, software supply chain becomes a pretty big, at least it's getting more visibility. Although if you've been in IT and doing any kind of programming, engineering, development, like whatever your role is in IT for a while, like software supply chain is probably like, yeah, we get it. But one of the things with dependencies in the software space, there's a mix. There's a ton of pros, there's a ton of cons. And the way that you go after those, or the way that you can approach and think about these things there's certain dependencies that are just intrinsic to the software we use every day. If you have, for example, a Mac, there's some core components of the Mac operating system that are based upon external components, external libraries. In fact, some of the stuff is rooted in like FreeBSD. Now, it's not that it is in that today as much as it is as a starting point, but there's all these different libraries that make things like securely connecting to your bank, making use of things called SSL or secure socket layer, or TLS, transport layer security, that these libraries make it to where programmers are able to make use of the library to do things like securely transact over the internet, and make it to where that interaction from your browser to your bank's servers can be secure, is something with confidence that you're able to send and receive things like your passwords, your balances, make transactions, and do things that make it easier for that programmer to focus on the functionality as opposed to having to worry about the entire stack. So those third-party libraries include, like as I mentioned, things like securing the transport, making sure that connection is secure. Oftentimes, there can be a dependency tree or a graph, like multiple dependencies. Like, I'm going to depend on something that Tim's created. And Tim actually has in that other package yet another dependency. And so that dependency tree, or that lineage of dependency, is something that is sometimes not seen. In order to help in a lot of companies, in order to help manage that supply chain, manage that end to end and all those dependencies, there are plenty of tools and a lot of good practices to make sure that those dependencies are clean of malware or clean of any types of vulnerabilities. There's also really good ways to make sure that the dependencies are well tracked, and there's versioning that comes into play, and a lot of really good approaches to making sure I need a specific version of Tim's library, that I can say, hey, I have this this version I'm going to pull in. And now I can, with confidence, understand the capabilities of that software. And if there is an issue, be able to say, either like open a ticket with Tim, say, hey, there's this issue. We need to uptick the version. I need a new version. Can you help me? And make it to where me using a particular version of Tim's library, even if there's a new version that's released, not breaking other people that are using that either that version or going to a new version. Because I may have a set of requirements or things that I need Tim's library. Tim's got this awesome library, but I need to do this one little thing. Tim may have like 10 other customers that are like, no, we don't care about that. So versioning becomes important so that we can create these essentially contracts that say, I'm going to create a new feature, but I'm also going to support these other versions to not break everyone at the same time. And then the last little piece is the human element when it comes down to like third-party libraries. There are times where a library just may go either orphaned or become abandoned, that there may need to either be new ownership or something where that library is just going away. And so if I am a user or I'm consuming that library, I want to make sure that I'm able to, based upon licensing and making sure that I'm doing all the right legal things, kind of keep a copy or a cache of that library so that even if it goes away, I'm able to, in the short term, continue to build my software and provide my service while I look for an alternative to make sure that I'm able to sustain what I have as a project or an application that's well suited for the environment.
Yeah, there's a lot to unpack in there. I had a few thoughts while you were talking. The first thing is there's a website that I'm gonna make Jenny look it up here after this. I'll try to track it down myself. But there's a website that I found a while back where the premise of the website was, when you want to visit Google.com,
mm-hmm.
what needs to actually happen under the hood in order for that to happen. And what they start with is like, see, when you type in, you have to type in HTTP. So what they start with this website is when you press down on the letter H, what happens to your computer? Like what does your computer do to respond to that key press, and how does that translate? And then it goes all the way from like, looking up the DNS, making the connection. Like it's super, super detailed. And the takeaway from that leads into the other thing I was thinking about is just everything that we've got here with technology is just, so much of it is just building blocks, one on top of the other. Of like, there's really very few programmers out there that I know of. I can't even imagine really any programmers at this point that aren't using some other piece of technology that they're standing on top of. Like no one is going down. I always say, like, computers are just, we tricked rocks into thinking. It's like, there's so
Sure.
many, like, there's so many layers to that of like going down of like I'm a Ruby on Rails programmer. That's mostly what I do these days. Cool. So it's like the Ruby on Rails platform is like, I have my hands like way above my head, and like Ruby on Rails is up here. And like, as you start to move down, it's like, okay, well, that's built on top of like just this technology, which is then you have to go down and it's built on top of this technology. And you get all the way down and it's like, I'm not even down to my hips yet. And it's still just the layers that we have built on top of this stuff is just, it's hard to believe. So my overall point with that is like, if you're building software or you're having software built for you, there's really rarely, unless there's some very specific, like, microcontroller programming or something that you're doing, for the most part, if you're building a web app to make your business better or something, that's usually like you're building on top of tons and tons of dependencies. And the way that you go about selecting which dependencies you build on is kind of like determining which house of cards you want to have your structure dependent on. And there's some are more stable, some are less house of cards and more, built out of concrete and cement. But even still, it's like all of this software is just layered. It's just layers all the way down.
It is. And, in thinking of like categorizing at the lowest level, think of it as like primitives. And then as you kind of could go from primitives to maybe something that's like a bundle. Like here's a couple of primitives that are together, and then eventually you get to like a pattern. And the next thing you know, you're like, oh, I've got this full stack. Let's go. A couple of things from that, even thinking about if I'm looking to get my engineering teams to think about, let's say we have several internal facing, so just to our employees, portals, maybe, a couple of different portals for like employee interaction, something like maybe not like HR systems, but like, hey, here's this documentation site, or here's this thing that I want employees to be able to hit up to. And if I get to like more than 3 or 4, but I have very different single sign-on or authentication ways for those employees to easily be able to find that site, get to that site, get on that site. One of the things that I can run into then is like these disparate ways that all like the same primitives are being used in a different set of patterns that make a very different experience. And now I've got employees going like, what is all this craziness? So in some of this where, in some of the things that we look at around trying to like normalize and rationalize the way that those different primitives or those different building blocks are built up is, are we able to simplify some of this to say, we don't need to recreate something like a single sign-on form if we have already something that's good enough, that's based on a solid set of practices and code, and like the community can go, yeah, this is good enough. Let's go with this. And then from that, be able to make it easier for us to add features to that common code base that's built on top of now a more structured house of cards. Like let's make the house of cards better and make it to where we have less fragility in like multiple systems to make it easier for us to manage that software supply chain, expand our community, even if it's internal, even if it's just like internal developers. And we at American Airlines, we make use of InnerSource. And InnerSource is similar to open source, except I guess the big differentiator is like we're happy to share internally, maybe intellectual property or the things that differentiate American Airlines. Like we'll build into our InnerSource projects those things that we think will make American Airlines better. And it could be like, we just want to simplify for employees, for our flying guests. Like here's a simpler way to do this, so you have a better experience from one thing to another. And as technologists, we look at our software supply chain as a mechanism to help accelerate the delivery of features, make them safer, whether it's mobile app or web app, or again, like anything internal. So I bring it up because, we may use an open source library as part of our InnerSource project. And what we want to do is get more people used to using that open source flavor of implementation, that library, so that we can be more consistent in our experience, the experiences that we provide for whomever our direct customer may be. Again, like people that are flying, or people that are at the gate, people that are within IT, people that, employees, that type of thing.
So I know open source specifically is probably a term that a lot of people listening to this have heard of, but might not really understand like what that actually is. And I think I really appreciated you going on the difference between open source and InnerSource, because like I think InnerSource would be code that you want to share internally with your team, but you don't want the whole world to be able to find it. Where
right.
Open source would be, you can go on, typically something like GitHub or some other code repository software and track down something that you're looking for. You can also find those open source libraries. What we'd say they're compiled, they're ready to go. They're in a format, like, again, being a Ruby on Rails guy, they come in the form of gems. You might have them in other kind of packages or whatever, using other frameworks. Right. But with what we use is we use these packages of code called gems that you can go out and find a gem that does, say, we use Devise, for example, as a popular gem for doing authentication, for signing people in and out and maintaining that kind of stuff. So instead of us having to, every time we write an app for a client and we say, hey, we want to use authentication, we don't have to go back and rewrite encryption and all this other stuff. It's like we can have a piece of code that's compiled in one spot, and we plug it in, and from there, it gives us a base that we can then customize and build on top of. But again, it's like you got to have those foundations in place. And kind of like to the point you were saying earlier about dependencies on dependencies on dependencies, the devise gem itself, when we plug that in, that's using a bunch of other gems inside of itself to be able to do things like encrypting your passwords and setting up like mailers so that if you need a forgot your password function, that's baked into the software. So I guess like, are there really any other key differences? Like when somebody hears open source, is that what would be a good summary of what that actually entails?
Yeah. I think that's a great setup and a great summary. So some of the key, I guess maybe just expanding on those key differentiators with open source, depending upon the type of license, and so open source itself is you have access to the source code. You may not have access to a specific distribution. Like it might not be compiled. You're giving you're like, here's a gem, and you're able to pull that package down. In some cases, open source might not have a compiled flavor. You have to compile it yourself, which is not that big of a deal. But the license piece is giving you as a consumer of that open source code some amount of flexibility to use it, usually use it how you want with certain rules. And I like to think about it at varying degrees of reciprocity. So there are certain licenses that say, if you use this code, you have to include the same license and you have to extend to anyone that's going to use your code the exact same permissions. Now, again, there are varying degrees. Some people may have heard of like copyleft, which is like, hey, if I use a copyleft license in any of the, with an asterisk and generalizing, any of the GPL type stuff is somewhat copyleft. Any of the, and there are some that are like you in maybe a different episode or different topic, like some you want to stay away from, and others you're like, yeah, let's use this. That license also can describe things like a disclaimer of warranty. People may have heard of like MIT license or Apache v2, where it's a little more permissive, and it allows you to, in those cases, it allows you to use the software, this open source code that you've come across, and it's like kind of use it however you want. Just make sure you're giving attribution. So if we pivot towards InnerSource, we intentionally don't apply a license. We do make sure that we're tracking and giving attribution to any open source we might pull in. And if we are pulling in an open source package into our InnerSource project that says you have to make available to your customer, your consumer, the same permissions as that library, that becomes sort of a decision point of, is this the library to include in that InnerSource project? Because just because it's InnerSource doesn't mean that we are not beholden to those open source license requirements if we are including those into our InnerSource code. And so there's a little bit of a boundary there that we make very clear internally to go, by default, if it's MIT or Apache v2, you're probably okay. Like to include that library. Just make sure you had mentioned using gems as a means to manage the Ruby, your Ruby on Rails, or even just in just plain old Ruby. That set of gems for your package or for your particular project, there's usually like a lock file. And for gems, it's gemfile.lock. And so that describes not only your direct dependencies, but then that is where you're able to describe all the rest of the dependencies. And that's that dependency tree. And being able to map and understand all the other dependencies and go, hey, all of this code that we're InnerSourcing is fine for us to distribute, and we don't have to redistribute the source code back out. We can start to build in differentiating capabilities like intellectual property into our InnerSource project. I'm not talking about, in some cases in enterprises, they talk about things like crown jewels, right? Like if you're a company that sells concert tickets and you have an algorithm to know exactly what price on what date to sell for what type of artist, the the optimization patterns for selling those tickets, that algorithm is probably not in, just the repo that's sitting inside of even under the corporate umbrella. It's probably like hidden away a little bit. Not talking about that type of intellectual property. I'm talking about like the implementation details that make it specific to that company. And that could be like, here's our IP address, or the way that we have our data flowing from an application into a data lake that then goes through an analytics engine to be able to provide us, more detail through like machine learning. Those are all things that we would put in code, and we would make use of InnerSource projects, especially on those common patterns that we want to make it easy for people to adopt, but we don't want to share with the rest of the world. And I think I just sort of like elaborated on what you were saying. So total agreement.
No, it's good to expand on that. And I'm glad you went into the licensing conversation, because that was where I was planning on taking it next. And I think that's one thing to really keep in mind, and something like I always try when I'm talking with non-technical people to find things that they can do to get them more comfortable with the area. And understanding open source licensing is one that I really think anybody can understand it with a little bit of just research and watching maybe a couple of YouTube videos. And I mean, obviously talking to your lawyer, because that would probably be a good first person to talk to. But it's not a hard concept. It's, there's a lot of like the underlying tools to get the things done. Those are out there as open source, but there are, like you said, there's different licenses that you have to be aware of. And I think it's because there's really two schools of thought around what open source means. Like, and those copyleft licenses come from a world where people want like all code to be free and want all code to be available to everybody, so that we can just continue to evolve. And while I appreciate that from like a human standpoint, from a business standpoint, you probably don't want to have your code subject to being reviewed by your competitors necessarily.
Right.
Again, for like the specific things that you do that are specific to your company, which I think that leads me to another question that I have about these. So there are sometimes I've come across situations where we need to get a specific thing done. There is a dependency that we can plug in and use, but that dependency is written with a GPL license or some other copyleft license, where it's like, okay, well that's a no brainer. We can't pull that in, so we're going to have to write this ourselves. When do you find it becomes better to and this doesn't have to be with licensing necessarily, I'm thinking of like anything around technology, but like when do you find yourself saying let's reach for a third party open source dependency, or when do we go ahead and build this ourselves? What are some of the distinctions that you make between those two?
Through the over the course of time, I think one of the pieces that one of the principles that I kind of carry with me on approaches to technology, approaches to architecture, and if it's in the application space, security space, what have you. But in this case, around like a mix of business and application architecture is, if I can buy for parity but build for differentiation, that's where I'm going to put my investment. So I think the distinction here is that if it's a differentiating capability, then I would rather invest in, even if it means having to build from scratch, put my engineering muscle there, and not put it in something where I could, whether it's third party, like third party open source, or potentially even just say, if I just go buy this other widget, am I done? Because if it's a parity thing, if it's just like commodity, like I don't need to I certainly am not going to do something like, let's figure out how to create a virtualization hypervisor so I can build more VMs. No, that's done. So I don't need to put engineering muscle there for me to solve business problems. What I do have is, in a competitive market, in a volatile market, I need a means to make, for example, American Airlines really attractive to flying customers. So if I think that tipping point of the parity versus differentiation is that piece there. And I'll go back to the tinkering that, we were talking about earlier on. When I was, so prior to coming to American Airlines, I was at Cargill. And one of the things that we had there was Cargill Digital Labs. And that was essentially almost, if you think of it like a startup within probably the largest company nobody's heard of, Cargill. But it like a little bit of a startup, and we were sort of like an IT seed factory, in that we were seeding ideas within, internally and externally, and going after through small prototypes where we scoped it really clear and said, with a certain amount of time and a known amount of investment of whether it's people, money, a set of outcomes that we're after, and a hypothesis, can we prove in like 4 weeks that we're at least able to solve one attribute of the problem statement by building it from scratch? And if what we found is that like it was just not going to work, then okay, let's pivot now, because we have identified, even if it was a dumpster fire of a failure, we have identified that there are enough gaps right now to make a little bit longer of an investment in just buying something, or making use of, like in some other method, or potentially saying like, it's just not worth it at all. Let's just not do something right now. Then to feel like we were forced into making like a long-term decision with short-term data. And that is something that at American Airlines, like we look at and try to de-scope all the time when it comes down to like, all right, so there's this library that's out there, and here are the concerns. Because another set of concerns, if I pivot a little bit on, like, okay, there's these concerns with it around like the license side. We have had folks that are very interested in an appropriately licensed open source third-party project that's out there. However, the activity in the community is diminished. The number of I'll just use GitHub terms in this case, but like the number of pull requests or the number of proposals to update the code is growing, and the number of reviews or merges or new features is diminishing. So people are wanting features, but it's not happening. And a bit of, I mentioned, the human element of like an abandoned or an orphaned project is also another set of concerns. Well, internally, the team's like, no, this is the right set of tools. We're willing to either contribute or own managing our own version of this open source library. Again, appropriately licensed, not a problem. We don't have to share it back out. Now the team is going like, we're willing to invest in us leveling up because it is the right tool. And that investment being like our skills, making sure we're able to sustain it, even internally, and then try to make use of that as a tool and a pattern for others to use, so that other teams aren't also trying to maintain their copy. So that differentiator there is like the team was willing, it was open source. We didn't have to buy something. And our investment then on differentiating was like getting our team members, getting our employees and our engineers skilled up to go after using that particular technology. So I feel like maybe I was starting to get on a tangent, so I'm going to stop there.
No, this is all, I'm just sitting nodding my head, because those are the exact things that I think about. Because one thing that I'll add on top of what you've said is when I think about evaluating a third-party dependency, I feel like, as I've been doing this long enough, and I haven't been at it as long as you have, but I've been building websites for like 25 years. So yeah. I've got some experience in the game, and I know, from my experience, there's so often a new, like JavaScript's the easy one to pick on. There's a new JavaScript framework that comes out, I would argue, probably multiple times a day.
There's 17 since we started recording.
Oh my God. Yeah.
Sorry, JavaScript friends. I'm kidding, but at the same time,
it's I'm joking, but I'm not joking, in that it's like there are so many with all of this stuff, like it's math, right? There's so many right ways to arrive at the same solution. And when it comes to dependencies, I've started to get to the point in my career where I'm like, you know what, just because it's been out for a while and it's old doesn't mean that it's bad. I try to, personally for me, I try to lean on whatever is out there that's been established is being supported hopefully by a handful of companies. Like you can look at any of the major frameworks, take the web as an example. PHP is pretty much entirely bolstered by Facebook these days. Rails is heavily supported by multiple companies. I mean, Basecamp probably being the biggest one, but there's lots of companies that are powered by it. Look at React is a Facebook property as well that is also being contributed to by a lot of big companies. But my point is that these are established frameworks that are well supported, that are going to continue to be supported for the foreseeable future. You can't always bank on a dependency being there forever, kind of like you had alluded to earlier. Like there's tons of times projects just go dormant, and it's the saddest thing in the world when you have to rip out your backup gem because that's been gone and you have to roll your own or find another solution.
Right.
But that's the space we live in. I mean, just because you lay a road doesn't mean you never have to repave it or redo it at some point, or every bridge that's out there needs maintenance as well. This is all part of the game. But for me, at least as it relates to which dependencies you go after and which dependencies you choose to adopt, there's a lot of factors that go into it. And for me, I think finding something that's stable and does the trick is big for me. And another philosophy that I try to live by as well is try to minimize the footprint of dependencies that you have as possible as well. Because I think that there's pretty often, especially this, I feel like this is more a front end thing than a back end thing, but I feel like there's a lot of times junior developers especially will figure out that there is like Node Package Manager, and you can go out and find, thousands of different packages that do charts and convert dates and do, so many different things. And it just becomes,
they're all like one character difference in name, or like,
right.
And so it's
and they're all,
yeah. Go ahead.
Sorry, yeah, they're all 20 megabytes too individually. So you've got like these dependencies that are making your software end up becoming way bigger than it needs to be because all of those dependencies have subdependencies. And do you think that those subdependencies are talking to each other? No, they're all getting their own version of that dependency to run. So you just have this massively inflated code base. I'm going to step off my soapbox now, but my point is I think for me it's find established dependencies that have been around for a while and don't use more than you absolutely need to.
Yeah. In that last little bit, like towards the tail end there, of the, dependencies that have subdependencies, and if they're the same subdependencies, then they're all bringing in their own. I'll tell you that the other side of that, and this comes from in the whole dependency. I don't know if folks have probably maybe have heard the term. If not, here you go. Dependency hell. And I'll tell you, there's, if we look at in some of the I'll say that the Nix operating systems, so like Unix, Linux, I remember having such painful implementation days because there would be a third-party dependency that was attempting to reuse a shared object on like a Solaris machine that was already there from another package, but because the dependencies and the versions were mismatched and there was no clear path for that dependency tree to resolve. Like I need version 2, but this other thing needs version 3, and neither of us are able to move away from our version. Then we end up with is like, all of a sudden, like the last one to install wins and breaks the other one. So there's that dependency tree where getting dependencies too coupled together is also like yet another danger point. But I think that kind of flows back to essentially what you are saying, and that is like if you can simplify that dependency tree and make it to where you're not pulling in like everything under the sun. That makes it much easier on the maintaining it as a whole. And I think there's a lot of really good packages and other open source projects that have come that are attempting to simplify some of those things. And I'll use an example. I'm a big fan of Fast API in the Python world. Fast API, and in my head, and the way that I kind of describe it to others is like, it's doing this great aggregation of pulling in other third-party components into like a stable runtime so that you don't have to manage those things. And yet at the same time, it is staying pretty, it's basically simplifying the equation of how do I set up a little API framework without having to go and even think about like, what's an ASGI server? Like, I mean, you don't have to worry about any of those things. And it brings in and collects like the best of breed, and then gives you a little bit of a domain specific language, a little bit of a DSL that says, here's a really easy way to do this. We'll manage all the things behind you without it getting into the weeds of like trying to recreate stuff. And I think that's I think another aspect of one of the things like at American Airlines that we're looking to do is, you had mentioned like PHP and you mentioned React, and there are these open source projects that are out there. There are other like complementary open source projects that are doing a great job of bringing together a set of open source projects that solve like with React, you can create a website, but then if you need data, it's like, okay, then now what do I do? Right. So you potentially need to like get down into the weeds a little bit on, okay, so I've got a front end piece. Now I need a back end piece, and now I need other components, and those components. And an example that comes to mind, and things that we have definitely been public about, is we have really enjoyed things that we're doing with Spotify's Backstage. And at a very macro level, it's like, here's some React, and then here's some opinions about in other languages and in other components, ways to bundle it together and make it easy for you to do things with React. Not necessarily just like, oh, now I have like starting from scratch with React. They're not recreating React. They're just like pulling it in and making it available for use, which I feel like that's right in line with, I bring that up because I think that's right in line with the, companies that support or help in making an open source project or a language, viable and really strong for the community. There's this new like level or tier, not new, but definitely something where, I feel like it's happening more and more, is there's projects that are helping bring other projects together to make it easier to solve problems.
Yeah. I keep thinking about Dependency Hell, and just that's where my mind has been, of just like, oh God, that is like, I think a lot of times people don't appreciate how much developers like don't actually get to write code. I feel like you spend, especially when you spin up a new project, or if you're getting integrated into a team, I think people expect, to be brought up right away and be contributing right away. But in my experience, it's like you pretty much have to decide to spend a day or two just getting your machine to get the dependencies to talk to each other in the right order. And then once it's set, you're like, okay, as long as I don't tilt my laptop 15 degrees and accidentally let one of these dependencies slip, then it's fine. Let's write on top of it. But oh man, I could go on that forever, but I feel like I got to get to our last question here, which is, I think when it comes to dependencies, like I wonder if like, obviously now we're best friends after doing this. If I were to come, if I were to come up to you and say, I'm really interested in learning more about dependencies and how they work, how would you, like, where would you direct me? Like, where are you going to find information about, like, keeping up to date with all of this crazy stuff in software here?
Yeah. So there are the common places like, hey, go check out YouTube and here's some keywords, or being able to go out to things like medium.com and here's some links, here's some, for Google News, check this out. I think more and more as we get so I think IT in general, and I feel like I've been like in the game long enough to see at least a couple cycles happen. And that is, IT is somewhat cyclical. There's a bit of a, like, every so often something new comes out and it's like, this feels like this is the, like, X, like Y is the new version of X, and here's how. And at the same time, there are I think there's a solid set of principles that I typically will point people at and say, if you're involved in IT and as a friend, sounds like you are, to like always make sure to kind of reflect on, like, what are the general design patterns and principles that you would approach any type of solution, so that if it's a matter of third-party software or managing dependencies, that you're able to conceptually and in a more concrete way be able to understand like the differences between being integrated and coupled to that dependency. So maybe it's like, all right, so let's be tightly integrated but loosely coupled. Let's make sure that and reflect on those design patterns, publish them internally into your team, into your organization, and make sure that it's rooted in people having the flexibility to try new things, set up those prototypes, get it to where you're in a position where you can experiment in small ways and with a very clear scope, and be able to share out, here are the things that we've learned by making use of this library, by making use of this new widget, and setting up that practice to where people have confidence in being able to try and experiment new things and share those pieces out. There are so kind of circling back to some of the common places. There's really good content about like application architecture design patterns that can help in describing and giving really good. There's really good videos out there on the various practice and principles that come into play about how you build up an application. And I think that's probably the main first thing that I would point people to. And then it turns into like, here's some specific links maybe, but.
Yeah, I would agree. Like I was thinking through, like, sometimes I try to think through how I would answer that question. And I think that is a hard one to just send somebody be like, here's the place to go for dependencies. But I think it is like, as much as, I think about a lot of times people make the comment about, oh, why do I have to take calculus in high school? Like, I'm never going to use calculus in my life. And then there's always that one point where you regret not having learned just the foundational principles. Like, yeah, you might not be doing calculus in your life, but understanding, like, possibly how a derivative could impact you one way. It's just another tool to have in your tool chest. And so I think you're right. Like with this, I think I was thinking specifically as it relates to when I went through computer science school in university, and thinking like, when am I ever going to need to learn this crap? Like I'm learning schema or scheme. I can't remember what the name of that one programming language where it's just parentheses like crazy. And I'm like, what is the point of this? And now looking back at it, you're like, oh, okay, you're learning the foundations and learning the basics. Like that is important. As much as I'd love to just jump right in and build something in Python or whatever. Sometimes just understanding the basics really does help to set you on the right path. So I think that those are really great places to start. Jason, where can people learn more about you and the work you're doing over at American Airlines?
Yeah, I definitely try to post things, for example, on like LinkedIn, sometimes on Twitter, and including whether it's content that we're things that we're working on internally within my space. I focus more on our like in our infrastructure world, in building up platforms for the other product teams to be able to use different cloud services and that type of thing. And so we do a lot of promotion of things that we're working on through American Airlines tech blog, which is tech.aa.com. But yeah, LinkedIn would be another great place.
Awesome. Sounds good. Well, thank you so much for joining me today, Jason. This was awesome.
Well, thank you very much, Tim. Hope everyone enjoys it. Thank you so much for having me. I appreciate it.
A big thanks to Jason Walker for joining Tim on the podcast today. You can connect with Jason on LinkedIn. Show notes for this episode can be found at constantvariables.co. You can get in touch with the show by emailing hello@constantvariables.co, or you can find us on Twitter at CV_podcast. Today's episode was produced by Jenny Karkowski and edited by the dashing Jordan Doust. As mentioned at the start of the episode, if you could please take 2 minutes to give us a rating and review on Apple Podcasts, we'll give you a mention in a future episode as a thank you. Visit constantvariables.co and we'll take you right there. This episode was brought to you by the Jed Mahonis Group. Check us out at jmg.mn.